So here's some examples of coterminal reference angles. This is just asking, identify all angles that are coterminal with each angle, then find one that's positive and one that's negative that are coterminal. So really just, this is your angle. All possible coterminal angles would be of the form plus or minus 360 times k. And whatever you input for k is going to give you a coterminal angle. It's got to be an integer, a whole number or a negative, and then that will give you whatever. So for the sake of argument, I'm just going to plug in 1. And then that, if you just plug in 1, it's just like you're adding 360 or subtracting 360. So 86 minus 360, if I subtracted, is a negative 274, and that is coterminal. Or if I added, and this is just saying I'm using k as 1. 86 minus 3, plus 360 this time. And you get 446. So that's coterminal. Same thing with 294. You could add or subtract 360, and this expression right here represents the set of all possible coterminal angles. So 294 minus 360 gives me a negative 1. If I subtract 360 times 1, I get negative 66 degrees, and 294 plus 360. And again, I'm just using 1 because that's all we really need. Gives you a much larger angle, but it's okay. 654 degrees. Okay, so that's an example of coterminal angles. This is kind of, it's asking a different question, but it's still using the same logic. We're saying if each angle is in standard position, determine a coterminal angle that is between 0 and 360. So basically just, these angles are already too big for one rotation, like if they go more than one full rotation. And so we don't really care about that first rotation. We just want to know where it ends up in standard position here. So all we'd have to do is, if it's bigger than 360, we're just going to take off 360. What that does is it eliminates that first useless rotation. It's not needed, and so you get 235. And then we could graph that if we wanted to. It would look just like this. You start the initial side right there, and to go to 235, you're just going somewhere. That's 90. That's 180, and then 235. Maybe it's like right there. We're at negative 777. Then we'd have to add 360 a couple times, because even if we added, let's say, if we added 360 twice, 360 times 2, that's 720. Even if we added 720 to this, it's still going to be negative. So we're going to have to actually add another set of 360. So times 3 is 1080. So again, all I'm really saying is we're going to have to add 360 like 3 times to this to get it to be positive. So I'm adding 1080. Okay, and then that's going to be negative 777 plus 1080, 303 degrees. So, and if you needed to graph that, you would just start at the initial side again, and it's positive, so we're going clockwise, or counterclockwise. 90, 180, 270, 303, and somewhere in there. Not exactly sure. Certainly before 315, which would be half a second learning target. So a reference angle, really the key thing is that we really only care about how far away our angle measurement is, in this case 312, is away from 0 degrees or 180. And note, and so those are the two angle measurements that are on the x-axis, that are the x-axis. But also, if you did a full circle, 0 and 360 are the same spot. So that would 360 is also considered one of the numbers we're looking for. So 312 degrees. If we started at the initial side, it's right here, and we went 312. That's going to be 90, 180, 270, and 312 is maybe somewhere right there. You don't really need to draw it out, but sometimes it helps visualize it. And so if you're at 312, the closest x-axis is 360, or 0, true, but you're closer to 360 than you are to 0. So if you just figured out this distance, then that's your reference angle. Ultimately, you're just doing 360 minus 312. So you'd get 48. And that's your reference angle. Okay, for part B, it's a little tricky here. You have negative 495. That's more than one full rotation. And it doesn't need to be positive, but it should be between 0 and 360, or really negative 360 and 0 too, just within one full rotation, either positive or negative. But I prefer it to be positive. It's just easier to think about. Then you're not learning two different rules, you're learning just one thing. But whatever you'd like to do. So if I added 360 to this, see where we end up. This ends up being 135, negative 135. And you can graph that. That's fine. So if you want, negative 135 is going to go this direction, past 90 in the abstraction, and then 135 is about right there. In this, since we're talking, negative, we went the negative direction. The x-axes are 0 and negative 135. Oh, negative 135 is our angle. 0 and 180 are our two x-axis angles that we're worried about, concerned with. So if we're at negative 135, the closest one's negative 180. How far are you away? And so don't get hung up on if I'm adding or subtracting. If I get a negative number, it's got to be between 0 and 90. You're only ever 90 degrees away from the x-axis. And so in this case, if you are a certain amount of degrees away, then I'm not worried about adding or subtracting. I'm just worried about how far I am away, which in this case is 45 degrees. To find a reference or a coterminal angle, whatever it is, it's just theta plus or minus 360 degrees times k, where theta is your angle and k is an integer. And then so it's coterminal. In reference, you just want it to be, you're worried about how close you are to 0 and 1 or 180, whichever one's closer. And maybe you're 97 degrees. So it's like over here, and if you went 90 degrees, you're right there. 97 is pretty close to that. You're closer to 180 than you are to 0. So you're just figuring out this distance. So basically, that's if you already went 97, how much more do you got to go to get to 180? And so in this case, you'd subtract the two. So that's what this lesson's about. All right, good luck.